Science with Folly.
Kia ora, Folly fans. Welcome to Science with Folly. Today we're learning about molecular shapes. A couple of things that we need to know. Firstly, electron pairs and covalent bonds, as you know, are made up of electrons. And these have negative charges. And remember, like charges repel, opposite charges attract. Therefore, these regions of negative charge repel for maximum separation around the atom they are attracted to. So let's look at methane, for example. Methane, CH4, is made of one carbon with 4 hydrogens around it. And this is obviously the Lewis diagram. But remember, these 4 areas are negatively charged. And so they don't just repel in 2 dimensions, they repel in 3 dimensions. Here's a little model of a methane molecule, and you can see how the hydrogens are all evenly spaced in 3 dimensions around the central carbon atom. And so we can draw a 3-dimensional diagram like this. Those little darkened triangles represent the hydrogens that are coming forwards, and this little Wi-Fi type signal represents the hydrogen that's going backwards, and this shows it's on the same plane. And around the central carbon atom, all the bonds, all the regions are separated out to 109 degrees. That's the maximum separation you'd get in 3 dimensions around a central atom. So there are 6 different shapes that you need to know, and you need to be able to explain these different shapes. Firstly, tetrahedral. CH4, methane. This is a tetrahedral shape. It's got a central carbon atom, 4 regions of negative charge which repel for maximum separation of 109 degrees. Second shape you need to know is trigonal planar. For example, CH2O, which is this one here, you can see even though it's got a double bond, that double bond only counts as 1 region of negative charge. And they're all on the same plane, which means they separate out for maximum separation of 120 degrees. Put him there. Linear. CO2, yet again, it has double bonds, but those double bonds only represent 2 regions of negative charge. They repel for maximum separation of 180 degrees. Bent, 3 regions. HNO, here we are. Now remember, nitrogen has a pair of electrons here. You can't see that, but that is pushing these 2 apart, and it's based on a trigonal planar shape. And that is why the angle is 120 degrees. Bent 4 regions, such as H2O. And yet again, remember this oxygen has got 2 pairs of electrons that you can't see. There's a bond angle of 109 degrees because it is based on a tetrahedral shape. And finally, trigonal pyramidal. And this shape here, NH3 ammonia, is trigonal pyramidal because it looks like a little pyramid. It's got 1 pair of electrons you can't see. It's based on a tetrahedral shape. And there it is. So I want you to try figuring out the shape of this molecule. Phosphorus trichloride, PCl3. Pause the video, have a go yourself. Firstly, what you're going to do is figure out your Lewis diagram. As you can see, phosphorus has got 3 lone electrons and 1 pair. That means it's got 3 bonding areas. Chloride has got 1, 2, 3 pairs and 1 lone electron. That means it's only got 1 bonding region. Put them all together. Here's our Lewis diagram of the whole molecule. And you can see there's 4 regions of negative charge. They're going to separate out for maximum separation of 109 degrees. But because there are only 3 covalent bonds, the overall shape is going to be trigonal pyramidal. And here's our 3-dimensional diagram like this. And remember, this is based on a tetrahedral shape. So just to finish, here's our 6 shapes. Can you name them all? Can you give their bond angles? And can you explain why they have the shapes they do? So I hope you've learned something. And if you haven't, watch it again. Ka kite anō. See you soon.
Science with folly. Science with folly. Science with folly. Science with folly. Science with folly.